Did you know a day is not exactly 24 hours and the length of every single day is different? I'm meteorologist Serena Arnold, and I love explaining sciencey, cool, crazy things to people in a way that they can understand it. Let's talk about it. Now, before you freak out, 24 hours is a very good estimation, but you have to know that it is just that, just an estimation. For the Earth to spin around on its axis and go around once and stop in the exact same place it started again, it actually takes 23 hours, 56 minutes, and 4 seconds. That's called a sidereal day, but we don't really pay attention to that because we actually base our time and our whole infrastructure based upon when the sun is back in the middle of the sky again. Like, when is it going to be noon again? To do that, because the sun is in the middle and we're orbiting around it, as we rotate around once, we've also traveled along our axis that goes around the sun. And so because of that, in order to get the sun back in the same place, we have to do a full turn plus 1 degree. And that takes up about that extra 4 minutes. But the time this takes actually changes every day. Looking at a chart from 1965 to 2025, we can see this is a zero line, and this is plus 1 millisecond, plus 2, and then minus. The length of the day actually changes pretty consistently. And it has. If we look back at data going all the way back until the 1800s, our days change a couple milliseconds all the time. I was tagged in another video to do an explainer of this because this has made the news recently. From space.com. And overall, Earth's rotation has slowed down over the billions of years that we've existed. But we're starting to pick up some speed again. But why? The moon's gravity and its orbit, which is what creates our tides, has a lot to do with it. Melting glaciers, earthquakes, volcanoes, even large-scale weather patterns that change like the distribution of mass across our planet can have a big effect on it. So think about things like floods. To make sure that over decades and centuries, that midnight on January 1st, we are in the same position in our solar system relative to the same position with the sun, they do little things like add leap seconds. The last time a leap second was added was December 31st of 2016. And historically, they've always been added, but with the recent spin up and us spinning just a little bit faster than we have before, for the first time ever, and they're not considering it yet, but looking ahead at the data, they may actually have to subtract a leap second for the first time ever. And ever means like relative to the amount of time that we've been keeping track of time in like a reasonable, like this is modern time stuff. The first leap second was added in 1972, and I think since then from now we've only added like 27 or something. So this is very similar to leap day and leap year, because it turns out we don't exactly have 365 days in a year either. Turns out from the time we start at one point on our orbit around the sun and get back to the exact same place takes 365 and a quarter days. In order to keep things kosher, every 4 years we add in February 29th, which is leap day, to kind of account for that. But that's not perfect either. That actually overestimates ever so slightly. And so every 100 years, we don't have a leap year, which underestimates it again. So to bring it into almost perfect and to build the system that we've been able to use and stay accurate for tens of thousands of years, every 400 years, they make an exception and you can have leap year again. So for example, leap year was skipped in 1700, 1800, and 1900, but in the year 2000, they actually added it back in and said, no, you can have it. We will not have another century that ends with double zeros that has a leap year in it at the specific time until 2400. 2100, 22, 23, all of those will not have a leap day, even though they're supposed to, if you count the every 4-year rule. It feels consistent to us every single day. There's a lot going on behind the scenes to make sure that we're in the same place at the same time for millennia.